The broadcast is now starting. All attendees are in listen-only mode.
Hi, and thank you for joining today's session on what if index analysis. This works with MS-SQL, Oracle, and DB2, and we're talking about optimizing performance while minimizing risk. So let's go ahead and get started. One of the things I like to point out is that the application cannot be faster than the database. Every business transaction ultimately relies and interacts with the system of record. Like it or not, the database is the foundation of performance. So we like to say database performance fuels company performance. And this is part of the reason why it makes sense to consider these different topics and strategies for getting the best performance possible out of your system. And the first topic is why invest in indices? And the reason, very succinctly, is they're super powerful. So let's just take a look at an example. This is the precise for Oracle expert view. It looks just about identical if you're running DB2 or SQL Server or Sybase. And what this is showing is the very top resource consumer. And this SQL statement executes a lot of times, almost 50,000 times. And each execution is pretty fast, a little over a second. But when you add that up, you're talking about hours worth of processing. And the processing is this dark blue, and that maps to using the CPU in the key. So we're not having to wait. We don't have a problem with storage. We're basically doing a huge amount of CPU. And when I look at the text of the SQL statement, I see select star. So right off the bat, I kind of categorize this as lazy coding. Select star returns all of the columns from the tabular view. And so it's basically creating additional work if some of those columns are not needed. And we've done our analysis on this and to improve it to see if we could buy back some of these hours worth of CPU processing. I want to show you what the B-tree index was able to achieve. First thing is we validated that the new index was being picked up. It's being used in a index range scan. And so one of the really important things anytime you're doing optimization is to measure before and after. And here we're basically just saying that after the new index is created, it is being used. The next step is to look at execution time before and then after. And so these numbers might be a little bit small, but let's just kind of review them. The average execution time had been 1.165 seconds. And for a little over 30,000 executions, it actually adds up to 9 hours, 54 minutes, 9 seconds worth of processing. Using the new index, we've actually dropped to sub-millisecond, and even though we've executed 58,000 times, the aggregated execution time is 7 seconds. And so when I save almost 10 hours worth of processing, when you consider that each core, CPU core, runs at millions of instructions per second, I've had an incredible ripple effect on the system because I've freed up a lot of resources. And let's take a look at those resources before and after. So clearly I've had a huge impact by adding one index. Well, what other indexes could I potentially make on my system? One of the things that Precise provides is it shows the objects and their usage over time. And so this PC affiliated person table is primarily accessed via full table scan, and the findings report shows us that. It reads extensive full table scans. The question becomes, if I'm doing all these full table scans, why do I have all of these indexes? Now, there is a primary key, _PK, primary key index, and that enforces data integrity. But what about these other indexes? Some of these are hardly used. Unused or underutilized indexes have a cost, and that is space and overhead. If your shop is not aging off history, and let's suppose you had a PeopleSoft conversion, you might have 17 years worth of data. and so some of these indexes might be quite sizable, and considering that I have many that are barely used, I might want to take a look at modeling, saying, what if I dropped these indexes? So let's take a look at kind of some of the analysis that you might do on your system to look at uh, tables that have too many indexes. So over-indexed tables has the potential to save space and conserve processing. Well, why conserve processing? The tables aren't only read, they're written to. And so anytime you do an update, delete, and insert, the index on that table has to be maintained, and that can add up. Precise offers a alert on over-indexed tables. And what this is showing is that this PRCS account has 7 indexes on it. And so let's take a closer look to see if there's anything that I might be able to do about that. And so I go in to the object view. This is the table. Here are the indexes. They're barely used. And what I can do is I can switch over and take a look at those indexes. And so the PRCS account, right, was created on February 1st, 2014. And it has all of these indexes. And we're showing here the statistics on those indexes. And so you can see here the number of distinct keys. And what you want is a lot of distinct keys, because that means that the index is highly selective, and when it's used, it will point to a small subset of the table, therefore saving I/O operations. Well, a whole bunch of these indexes are barely selective at all, and they're not going to do me much good. So let's model, take these into the What If tab to say, if I were to drop these indexes, what would be the implication? So we go to What If, we specify the indexes that we would like to simulate index deletion on, and we click Evaluate. Now, before I click Evaluate, I want to explain this. Precise has a historic repository. We capture the SQL statements in their execution plan, so we know what SQL statements access the account table. And when I do this evaluation, we're going to go through that repository and ask each SQL statement that uses the account table, how would you be impacted by this proposed change? Would the cost go up? Would the cost go down? Would there be no impact? And when I click Evaluate here, it actually tells me that 0 SQL statements would improve and 0 SQL statements would deteriorate. And what that means is that I'm able to safely drop these indexes and have minimal impact on my system. Now you might say to yourself, well, how could I use that, or how could that help me? I want to share with you a war story. We had a customer, a trucking company up in Calgary, Canada, and they used PeopleSoft. And their accounts receivable process would not come to completion in a 24-hour period. And after running for over a day, they killed it. And in fact, they went through this multiple times. We went ahead and installed Precise. We found out that as part of the accounts receivable process, is to load the day's accounts receivable via an insert. Well, there were so many indexes on the table, that's what accounted for all of that processing time. We used the What If to kind of say, if we drop these indexes, what would be the impact? And so we minimized the risk that we would actually have a negative impact on the application, went ahead and made the change, and voila. That same process, even though I had multiple days of workload to catch up on, was able to complete in several hours. Now, because of the emergency situation, they actually had the other vendors there. Not surprisingly, the server vendor said, oh, you need a bigger, more powerful server with more CPUs. No, they need to use the technology correctly. The database vendor said, oh, you need to upgrade the database. Once again, no, they just needed to utilize what they had in place more effectively. And that's what Precise can help you do for your systems. And so let's go ahead and move on to the next uh, scenario. Now here, we're going to actually use the recommendation feature in combination with the modeling. So we have both, hey, what indexes might be helpful, as well as if you were to create or drop these indexes or even change the indexes, what would be the implication? Now, one of the things is that not all indices are helpful. Some could actually negatively impact processing, negatively impact the workflow. Incidentally, we're making great time, and so no need to beat around the bush. Let's just share the information, be as efficient as possible. So here we're going to go from an end-to-end transaction view, focus on the Oracle tier. But what we've done is we've put the SQL statements used by a particular Java transaction. So what I'm looking here at is the Java caller last account history. Many applications have an account history, so this type of thing is not uncommon, and there's always kind of some derivation of the 80-20 rule in that this SQL statement is the heaviest contributor to this transaction. So I click Tune for this SQL statement, and you can see here the execution plan, and that 99% of the time is spent doing a full table scan. We are using parallel, so that's a bonus. But guess what? Uh, we've we're basically using this full table scan, which means that we're reading all blocks of the table, and Precise has statement level findings with recommendations. And one of the things we might do is click on the recommendation, and that will basically say you might consider a new index on the user info table comprised of ID and username. And the what if analysis, when I click evaluate, will go through the repository and look for SQL statements that would be impacted. Unsurprisingly, it pinpointed the SQL statements that were used by account history, and it would actually say that the cost would go from 269 down to 3 for a 99% performance gain. And being that we're going to save so much time, that's going to clearly have an impact on the end user community and on the time of that total transaction. Like we said, every business transaction relies on a SQL statement or set of SQL statements, and the transaction cannot run faster than those SQL statements. In fact, the SQL statement execution time directly is added to the total execution time of the transaction. So here we've delivered a nice performance gain to our end user community. You also saw something there that was really potentially impactful. Is I wasn't just tuning at the database level or the instance level, I was actually tuning at the application transaction level. Precise is able to actually show what SQL statements are used by which transaction. Very, very powerful use of this solution. All right, let's kind of move on. Now, a lot of times we'll talk to a DBA and they'll say, look, my application is ad hoc reporting. I've got SQRs, I've got Crystal, I've got Envision, and I basically don't control what the reports are. Or maybe the other side of it is you have a third-party application. You have a PeopleSoft, an SAP, an e-business suite, and they come delivered to you with generic indexes that may or may not address the processing needs of your application. So in either scenario, basically looking at the workflow, looking at the SQL statements, and then saying, well, is there a set of indexes that could ideally address this processing? It allows me to basically address these issues when I don't control the SQL statements whether ad hoc report or third-party application. So let's drill in a little bit to take a look at this. First of all, Precise's findings report at the instance level shows me not just SQL statements, it also shows me what objects are heavy. And I basically have almost a tie here for first place. I've got the test data, I've got the stock table, and together they're responsible for about 50% of the processing on the server. And what I can do is focus on the activity coming from the stock table. Now, there's also built-in help. So when I click Learn More, this information about, how do you tune a heavy object? And the advice is to take a look at reads versus writes, the access paths of the SQL statements. How is it being accessed? Full table scans, range scans, on and on. I also want to just point out here is that Precise has a comprehensive library of findings, and whether it's at the instance level, at a SQL statement level, at the object level, Precise is going to give you solid recommendations on how to improve things. Now, if you're a seasoned DBA, you kind of think, well, I kind of know this, but sometimes Precise might give you something that you hadn't thought of before, or if you're a new hire, or everybody, hey, these databases are so complicated, we're all constantly learning. Sometimes there can be advice that can be extremely helpful. Now, what we've done is we've clicked on the activity button, and we're looking at the stock table, and we've correlated to the SQL statements that use the stock table. Now, let's just kind of back up for a second. Please consider, in the case of reporting, most of the time in a business setting, people are saying, well, what happened yesterday, last week, last month, last quarter? And what you end up finding is that there's commonality in the where clause. What are you filtering on? What are you ordering by? What are you sorting by? And so it might be department, it might be revenue, and so you're going to see commonality in those SQL statements. And once again, that implies that there's indexes that ideally address the needs of that workflow. And so for that, you would use the recommendation and the what if analysis. So we go into the objects view. First of all, we look at this stock table, and it's almost exclusively full table scans. And we might want to get a recommendation idea about indexes that would be helpful for all of the SQL statements that use this. And the recommendation engine actually comes up with two different indexes on the stock table. And now what I'm able to do is evaluate those two recommendations. Incidentally, I could evaluate them one at a time, or I can evaluate them together. So let's click Evaluate, and Precise will go out and do an analysis, and it's saying, wow, there's 26 SQL statements that would improve. There's none that would deteriorate. And kind of the historic resource consumption in Oracle was 2 hours, 15 minutes. Now, with this new index, it drops down to hours, minutes, seconds, 23 seconds. So I've saved over, well, a little over 2 hours, 15 minutes worth of processing. Once again, that has a huge ripple effect on my system, and that's spread across 2,624 executions. Now, you might say to yourself, well, wait a second, this SQL statement is doing select max, the SID table from stock. There's no filtering here. How could it benefit? Well, if I create an index on the SID table, which is right here, that's actually going to be accessible. So I don't have to read the whole table. I can actually read the index. It's going to save IOs. It's going to save a lot of processing. And that's how I come up with this huge time saving. And when I look across this entire workflow, hours down to seconds, hours down to seconds, I'm having a huge impact on my system. And doing this type of analysis from the object perspective can have extremely powerful impact on your reporting. a lot of shops struggle with having the reports out ready for management first thing in the morning. There are some other tools that can do object analysis, but typically capturing the SQL statements has an extremely high overhead, and you don't want to do object monitoring. But due to Precise's clever architecture, I would say, we're able to gather this information 24 by 7, and we have experience doing bake-offs, so I'm pretty confident in saying that Precise is the lowest overhead commercially available database monitoring solution, including any of the solutions offered by Oracle, SQL Server, um, or IBM, Microsoft or IBM. Of any of those tools, we have the best visibility at the lowest overhead. And from a business perspective, I'm sure our sales reps could come up with a very compelling offer. So the question is, why not? And when I'm doing this type of processing, and I'm meeting my business goals, getting my reports out on time, has a huge benefit to your business potentially. So let's talk about tuning risk. Anytime I make a change, I could impact one SQL statement, or I could potentially impact all SQL statements. And I attempt to present that to you in this triangle of database optimization success. And for fans of HBO's Silicon Valley, you might kind of recognize this. So at the top of the pyramid is one single SQL statement. I can achieve a different execution plan by rewriting. I can add a hint. At the bottom of this are system-wide changes. I might make a change to the server, to storage. I could change a parameter setting in the database. Once again, that's going to impact potentially all SQL statements. These changes kind of at the hardware level tend to be the most expensive. They also have the most impact. In the middle is actually changes to the indexes itself. And this whole presentation has been about recommendations and what if to model these changes. And I want to point out that you don't necessarily need to add an index or drop an index. You could start by simply rebuilding the existing indexes. And I would highly recommend this, and I'll get into the reasons why in just a moment. And then you would want to take a look at your existing indexes, consider new indexes, consider dropping indexes, consider partitioning. Partitioning is very powerful because rather than have to read all of the data, I can segment it and read just a fraction of the data, and that can be very powerful. Once again, it's astonishing to me how many shops do not have archiving. Archiving is also a way to minimize the amount of data in your system, and therefore when I have to read all of the data with a full table scan or a full index range scan, I can minimize the length or the duration of that scan. So let's take a look at bad indexes versus healthy indexes. And one of the things I want to point out is that when I do an I/O at the operating system, it's done at a block for a data table. It's done at a leaf page for an index. And so same concept, the unit of storage that an I/O is done on is not a row, it's not a table space, it's actually at the block level. Now, if I was to draw an analogy between doing I/Os on blocks, a block would be akin to a shipping container, right? So I go to the database, the database goes to storage and brings back a whole bunch of data. Couple of things here. Each shipping container is a block. A shipping container could have no data, it could have one row, it could have 1,000 rows. Obviously, if the shipping container is filled with rows, that's going to be more efficient than bringing back an empty container. No, reputable, company would ship around empty containers. You want to basically load them up for both legs of the trip. And so So likewise, how do I load up the containers? Your system over time is going to have fragmentation. Anytime you do a delete, the row is simply marked as deleted. The space is not recovered until you take action. Likewise, when you insert rows, you can actually cause an index split because the data doesn't fit into the block, and so the database has to open up a new block to fit that data. And so over time, the data is going to become extremely fragmented. You can use IDERA's defrag manager to automate that for SQL Server. You can script it out, and you want to do this on your busiest objects to keep them as healthy as possible. One of the things is that all of these things are interconnected. You have SQL statements that drive I/O on tables. So it's both a combination of the table as well as the SQL statement that cause the I/O. Now let's take a closer look at indexes. This is kind of an advanced topic, and I hope I can explain this well. This is the table. This is the index. So if I have a single lookup, I read the root, I do an I/O, I read the leaf page, and if I'm getting one particular row, I read the data block. So I/O, I/O, I/O. But let's suppose that instead of reading one distinct row, I'm doing an index range scan. I'm going to bring back multiple rows. So I could do an I/O, an I/O. Now I bring back this row. Unfortunately, I did an I/O on this page, but the second row is actually on this block. And so I do an I/O of this block. Then I have to do an I/O of this block. I do an I/O of this block. Then I read the next leaf page. I'm going back to this block. Then I have to read this block. In the very worst case scenario, I could, in an index range scan, have to do an I/O for every single row in the table. And if I have extremely large tables with billions of rows, that means I'm doing billions of I/Os, right? Don't, now, wait a second. Don't blame the storage administrator if you have your system configured to do billions of I/Os. Now, the reverse scenario is an index where the table is sorted in the same order as the index. And then, in that case, I read the root, I read the leaf page, and when I do an I/O on the underlying data table, I bring back all of the rows or multiple user rows in one I/O. So this is going to greatly reduce the number of I/Os. There's another technique I can do, and that is, suppose that I just needed 2 columns. And if I add the second column, I can pull it directly from the leaf page, and I don't even need to go to the data table. So I just read the root, I read the leaf page, I've got all of the columns that I need, and the SQL statement is able to do its business. That's called a covering index. Once again, a covering index includes all of the columns that are used by a SQL statement, and it basically skips the step of having to go to the data table. Let's see how we can put this information to use. This is kind of very academic. I hope you stuck with me through this. So, and this is an example of good to great. So I have this process, takes 5 minutes to complete, and I analyze it. And this is a SQL Plus process, and it has a SQL statement that executes really fast, right? Tenths, hundredths, thousandths of a second, 15 thousandths of a second. A lot of executions. Incidentally, one of the ways that Precise distinguishes itself is it samples at a minimum once per second. And if you compare that to products that sample once every 5, once every 10, once every 15 minutes, the order of resolution, orders of magnitude resolution is going to be a lot higher with Precise. We're going to give you the true profile of the SQL statements that are running on your system. Now, what I do is I click this Tune button, and we take a look at the execution plan, right? And we see that it's using an index. And that index is comprised of first name. It has a lot of distinct values, so that's good. It's highly selective. But when I look at the text of the SQL statement, I'm filtering on first name. So this index is going to be awesome, but I'm also grabbing the column amount. And that means I have to traverse from the index to the base table. Remember that from that kind of overview? So if I added the amount column to the index, I could skip that step. And although this SQL statement is very fast, I could potentially make it faster. And incidentally, when I evaluate this index, the metric that expresses the IOs associated with an index used in a range scan is called clustering factor. This is an Oracle term, but it applies likewise to SQL Server and DB2. And so when I use this index in a range scan, and I am here, index range scan, it's going to basically do a lot of IO operations, hence the CPU, hence the amount of time I spent on accessing the storage subsystem that was shown in the previous screen. So let's go ahead and make those changes. So I'm going to create the new index based upon the two columns. I'm going to analyze it. And what I see here is, so I've done each of those steps, and I've basically validated that I'm picking up this new index, and it is indeed comprised of first name and amount, right? It's highly selective, and I can get all of the information from that this SQL statement needs directly from the index. And that's going to save me a step. And that step basically now pushes the execution time from 15 down to 4/10. So I basically dropped the execution time by 2/3, and that's going to ultimately impact the process on my system. So now it's basically a little bit less than half to complete that PL SQL package. And that's an example of good to great. Yeah, we could have lived with it, but guess what? If I work in finance where time is money, this little change might make a big difference in what I'm able to do for my company, what the end users, the application, maybe the traders, the brokers are able to do for their customers. So they can have a huge impact on on your business. So kind of just very quickly, Precise for database, and we're talking about Oracle, SQL Server, Sybase, and DB2. We offer monitoring, availability. We're always on 24/7. This is not a product like our competitors. Our competitors actually force you to turn on additional visibility after you've had a problem. So you're always reactive. With Precise, using the techniques I've shown you, with having the best set of indexes possible, that is the minimum number of highly selective low cluster factor indexes, they address the processing needs that Precise's historic repository shows you, can save you this, avoid contention, avoid locking, avoid alerts. We put the information in context of the login, the program, the machine, so that you're able to drill down and have an application perspective. And you can also share information with all stakeholders via dashboards, long-term reports, as well as alerting, so you're not dependent upon your end user community to tell you when there's a problem. Now, if you liked what you saw here, and you can take the information, use it. You don't need to have a product to use this information, but if you want to explore this product further, I want to show you how to kind of see it for yourself. Go to IDERA's website, go to the products page, you'll find Precise. No matter what the product is, just click on Precise, and that's going to bring you over here and click See It in Action. And that's going to connect you up with the Precise team within IDERA, and we'll be happy to facilitate an evaluation at your site. And with that, that's the information that I wanted to present to you today. Very much appreciate your attendance, And with that, I'm going to call it a webinar. We will post this on our community site if you would like to review it. If you have any questions in the chat window, I posted my email address, bill.ellis@idera.com. Gentlemen, ladies and gentlemen, thank you very much for your time. I'm going to go ahead and close down the webinar. Thanks again. Bye-bye.